Good morning. Today I Ganesh Rodki will be presenting on the analytical instrument Haze Meter. So before we move on to what actually is a Haze Meter, we first need to understand what actually is haze and transmittance. Terms like haze and transmittance. So these are the table of contents which we'll be discussing today. So firstly, what is haze? Haze describes the cloudiness or the loss of clarity in transparent materials. It is often due to light scattering caused by surface imperfections or internal defects. We express haze as the ratio of scattered light flux to the total light flux passing through a material, presented as a percentage. This metric is important because it influences how transparent or cloudy a material appears. Samples with high haze give a more blurry impression, while those with low haze appear much clearer. Typically, light deviating more than 2.5 degrees from the original path is used to measure haze. Now, what is transmittance? So, transmittance refers to the measure of light that successfully passes through a material compared to the original amount of light that strikes it. During this process, some light is lost due to reflection or absorption. Transmittance also is hence transmittance is expressed as a percentage and is essential for understanding a material's optical properties which affect its clarity. So the main reason for the decrease in transmittance is the reflection of light of the two surfaces of the sample and the absorption of light energy at all or part of the wavelength of the incident light by the sample. So now that we know the two main terms, what is Haze meter, or also known as turbidity meter? So Haze meter, it is a basically specialized equipment which is used to quantify light scattering and transmittance. It evaluates how much a material causes a light to scatter, thereby determining the material's transparency. This is particularly crucial for quality control in industries that rely on optical clarity such as automotive and packaging. So now these are to properly understand the transmittance, we need to first understand these four terms. First is the incident luminous flux, which is the total light entering the system. Transmitted luminous flux T2, which is the amount of light passing through the sample. The instrument scattering luminous flux T3, which is the baseline scattering caused by the instrument, and total scattered luminous flux T4, which is the combination of sample and instrument scattering. So combination of sample and instrument scattering is basically the summation of T2 and T3. So from here we can get the formula of transmittance, which is Tt equal to T2 by T1 to 100 percentage, and Haze is equal to T4 by Tt, which is transmittance into 100. So what is the working principle of Haze meter? So basically, when a parallel beam of light is incident on a certain medium, such as glass or plastic, due to the non-uniformity of the optical properties of the material, surface defects, and uneven internal organization, impurities, etc., it causes the beam to change direction, which results in scattering of the light. So here you can see it is a well explained picture of working principle of the Haze meter. So here you can see the light source, which here the light source is throwing the parallel incident beam of light towards the sample. The sample here containing the impurities, bubbles, and uneven surfaces causes the parallel beam of light to deflect and scatter. So these deflection and scatter causes an uneven distribution of light inside the integration sphere. This uneven distribution of light is catched and detected by the detector, which gives us the properties such as haze and transmittance. So here is the live working of a haze meter, which I'll be adding in the group description. So before we move on to experimenting, first we need to understand how the sample needs to be prepared. These are the prerequisites for the sample preparations. Firstly, The sample should be of proper shape and size. It should be in the form of flat, smooth sheet, a flat, smooth sheet. The size and thickness are often specified by industry standards, which is 10 centimeter into 10 centimeter, or as required by the instrument manufacturer. Also, the surface conditions should be dust-free, fingerprints, scratches, or smudges-free, as it can affect the haze values. Also we should first also it is the sample is to be cleaned with soft cloth and tissue to avoid changes in the fluctuations in the values in the experiments. Also, while handling the sample, we should use gloves to avoid fingerprints and oils on the surfaces, as it can affect the haze and transmittance percentage of the sample. Also, positioning of the sample plays a crucial role, as it will ultimately affect the amount of incident light in entering the sample. So now that we know what haze meter actually does, how is it different from other optical analytic instruments? So one major optical instrument, which is spectrophotometer, it measures the transmittance and absorbance across a range of wavelengths, providing detailed color and transparency information. Whereas haze meter specifically quantities scattering light that causes haze only on a particular wavelength. Also, the second most used is the gloss meter. So gloss meter, which usually focuses on surface reflection and provides gloss units rather than haze percentages. So these are the main applications, industrial and practical applications of haze meter. So which is first is plastic and packaging. Haze meter mainly used for assessing clarity of food, bags, and consumer goods packaging. Low haze and high transmittance ensure product visibility at the point of sale. So also automotive industry such as headlights, tails, windows ensure clear visibility for driver safety and regulatory compliance. Various optical and photonic products such as lenses, filters, space equipments, etc. They use advanced optical system which needs to be properly experimented with the haze meter. Also, in today's times, various electronic and display technology, such as smartphones and tablets, for their mass production, they need to be properly tested with the haze meter for good clarity for the screens and good user experience. Also, other paints and coatings also are assessed with the haze meter for transmittance through them. Low haze and high transmittance are necessarily required for visual appeal and durability. So these are some limitations of haze meter. First is the material constraints that as the haze meter are typically used only for transparent or translucent materials. They are not they are completely useless against opaque or highly reflective surfaces. Surface quality sensitivity such as means that it is highly sensitive against scratches, dust, or fingerprints, and affects the results and output of the haze meter significantly. Also, like how the spectrophotometer works on the majority of wavelength, haze meter has a limitation such as it works only on specific range of wavelength values, and gives specific haze values only. Also, another is the uniformity requirement, as the haze meter provides best results on the sample. If they are in uniform thickness and optical properties, even a slight inconsistencies can lead to varied results. Sample size restrictions like minor restrictions such as needs to fit the device holder can limit the testing for large irregularity shaped materials, and other environmental factors such as temperature, humidity, lighting conditions may affect the overall results of the sample experimenting through Haze meter. Thank you.